Do you want the walk around, Mike?
Oh yeah, I'm definitely gonna be moving for sure.
Okay.
Oh sweet, that's actually fantastic. It's right there. I didn't even realize. Yeah. Alrighty, hi there. My name is Eric, and today I'm going to be talking to you about how we can or cannot find maternity colonies using acoustic monitoring. I am a grad student at Carleton University. I am learning from the amazing Christina Davey back there, and I work in collaboration with the Toronto Zoo, Toronto Zoo's native bat conservation program, which is spearheaded by the legend himself, Toby Thorne, sitting in the back over there, standing at the back. And let's go. Oh, the other green button. All right. All right, so a little bit of background here. Humans like to grow and build into landscapes that they weren't originally in, and that leads to a lot of loss of habitat. And they do that to forage. And during maternity, reproductive females have high energetic demands and are likely to forage. So what we want to know is, to find a roost, we need to know if there's a relationship between the time since sunset and the rate of passes picked up at a monitor. And we also need to know whether the distance to a roost relates to the rate of passes at a monitor. And those two pieces combined might give us the ability to predict maternity colony locations. So that's what we did. I started my first field season in May 2022. I went to Scarborough, Ontario, where I worked with Toby and his team over there. And we looked at 3 colonies of big brown bats, maternity colonies of big brown bats. During the summer of 2022, we set out 12 monitors surrounding each roost, and we set them out for a week, and we did that for 1 week for each of the maternity colonies. And the transects of passive acoustic monitors were placed equidistant to each other, going away from the roost for 500 meters. But after completing that field season, we had some thought about what we were looking at, and the output of this project was to try to figure out if there is a pattern of dispersal surrounding maternity colonies, not to actually develop an effective tool to find maternity colonies. So we put ourselves out there to try to, so we wanted to find a pattern if there was one, and so we wanted to look at each of the quadrants as well, because there might be a pattern within that area that we weren't previously studying. So in 2023, we came back, and it was pretty much the same, except we had another roost, and a lot more monitors. So we set out 49 passive acoustic monitors in a 1 kilometer squared grid, and we did that during 3 study periods. Once during the pregnancy period, which we defined as the end of May, early June. Once during the prevolant period, which we put in as the end of June, start of July, and once in the post-volant period at the end of July, early August. So each of the roosts were studied once during one of those periods, and we put them out for 1 night. We went in the afternoon, and we put out 49 monitors on rebar poles, waited till sunset, recorded them for an hour, and then lovingly took them out of the ground that exact night. A lot of fun work. Toby loved it. And so what did we do to look at this data? We were looking at the rate of passes per 2-minute interval, and we used a zero-inflated negative binomial mixed effects model, or as I like to call it, a ZINBMM, to look at the effects of our predictor variables. Our first predictor variable was time elapsed since sunset, and the other one was the distance of a monitor to the roost. We also included the distance of a monitor to the nearest forest edge and nearest riparian edge, because that is where bats forage, so it's likely that bats that, or monitors that are around those bats, around those areas, will record more passes than those placed farther away from them. We use site and study period as random effects because sites are of different size, different amount of bats live in each maternity colony. So it's likely that there might be some changes in passes based on site, and also during different maternity periods, because later on there's more bats there, hopefully. So what did we find? A little summary is, well, we did 13 total nights between 2022 and 2023, 3 nights in 2022, and 10 nights in 2023. We found a total of 5,286 bat passes, and looking at the graph, we can see that some sites actually get a lot more bat passes than others. Site B was right beside a river, and it was a lot of forested area. Pretty great for bats. So what did our model find? Well, we found a significant effect for the time elapsed in sunset on the rate of bat passes. We found a significant effect of a monitor's distance to the roost on the number of bat passes. We found a significant effect of a monitor's distance to forest edge on the number of bat passes, but we did not find that same significant effect for the distance to riparian habitat. that was kind of interesting because bats forage a lot, and there are a lot of bugs in those kind of places. But so I went and looked into it, and I found that it's probably because Solris, the Solris database that we used is at a 50-meter resolution, and a lot of the riparian habitat that we have is smaller than that, so a lot of it wasn't actually shown. Our random effects accounted for 49% of the variability, and site was approximately 30% of that. But all of the effect sizes were very, very, very small, to the extent that distance to roost was had the greatest impact on the number of bat passes, and that only accounted for about a change of 1 bat pass in the entire 500-meter span away from the roost. So what does this all mean? There are relationships between when a bat is in a place and how far it's from the roost, but the relationship is too small to use as a predictive tool. That means we should probably not be using passive acoustic monitoring alone to locate bat maternity habitat, but that's not to say that we can't continue to use it as we are using it now to better inform and reduce the survey efforts of techniques that can validate the presence or absence of maternity habitat. Thank you very much, and I'd like to say a special thanks to Christine Davey and our wonderful lab, also Chloe from Carleton, who did a lot of work with me and put up with me for like 2 years, and Alex and Alana from the Toronto Zoo, also great people, and obviously the landowners whose land I used, and they were super interested in my science, so it was really cool. Thank you very much.
This isn't, there we go. Any questions? I don't see hand. Oh, okay, we got one.
How many, you said you put up 49?
Yep.
Passive. How many people did it take to put up 49 detectors, and how long did it take you to put up 49 detectors? That seems like a labor of love.
So that is, yeah, people weren't always happy to work on my project. I loved my project. Toby obviously loved my project a lot and said he would do it again next year with me if I wanted to. It took depending on the site, because if it was a lot of farmland around it, say corn, earlier in the season, it was very, very fast, like a couple of hours, maybe a little bit less. But that one site where I said there was a lot of rivers and dense forests, July could take like all afternoon. We go to like early afternoon and we do it till sunset, and we just finish in just the right amount of time. In actuality, we had to come down the next day. Sometimes me and Chloe went down and removed the excess monitors. We removed as much as we could the night of, and then did some extra work in the morning. Yep, it was a fun field season. Great exercise.
Great. Okay, any other questions? No hands up. I have one question for you.
Let's go.
So in that grid, were you able to correct for any other like smaller roosts that could have occurred that you didn't know about, like somewhere else near those detectors?
No, we did not. There might be. So it depends on the site. A few of the sites had a few buildings near them, and a few of those those clustered buildings had roosts in them. But we didn't really see that many bat passes, and I'm trying to think just anecdotally here, but I do remember like data points in one site coming out earlier than the ones leading away from the site, and it could mean, but it's very difficult to know whether or not. These are just some of the known sites that we knew around the area, so yeah.
Okay, thanks very much, Eric. Oh, so I guess there's one more question from the live stream, right? Okay. We'll have Brad read the question.
Thank you. We've got a question here online. It says, great study. Do you think you would have got a better or a different result, pardon me, if you had chosen a species that doesn't fly as far from the roost at night? Also, big browns may be using upland foraging for beetles.
Yeah, that's a really good question. It's something I've thought about a lot, that our scale of study is not reflective of the species. But looking at foraging ranges of big brown bats, they actually are within that scale of study as well within their foraging range. Some studies find that they forage at lower distances or slightly greater distances to a lot farther distances. But if you pick up different species, the objective of the study was to give the best case scenario about getting that dispersal, identifying a pattern in dispersal. And if we were to use, say, just what's on my mind right now is a tricolored bat, because I don't know. If we use a roost of a tricolored bat, well, you're going to be dealing with a lot less bats. You're going to have, we only know of one in Ontario, and that's not the best case scenario. We don't really know a lot about their ecology either. We do know a lot about big brown bats and how they move around the landscape. So their abundance had something to do with why we chose them.
Okay, thanks very much, Eric.